Welcome to Study Loop.
For this problem on the topic of waves and sound, we are told that a long slender bar is made from an unknown material. We are given the length of the bar, its cross-sectional area, and its mass, and given the time that a sound wave takes to travel from one end of the bar to the other. We want to determine from which material this bar is made. Now, we know an equation that relates Young's modulus y, the mass density and the speed of sound in a long, slender solid bar. And we know Young's modulus y is equal to the density of the material rho times the speed of sound in the material squared. Y is equal to rho v squared. Now, we can use the values of the data given in the problem statement, and we can find the speed of sound in the bar. Now, the speed of sound in the bar, v, is equal to L over t, the length of the bar divided by the time. So the bar is 0.83 meters, and it takes 1.9 times 10 to the minus 4 seconds for a sound wave to travel from one end of the bar to the other. So we get the speed of sound in this bar to be 4.4 times 10 to the power 3 meters a second. Now, the mass density of the bar, rho, is equal to the mass over the volume. And we can write the mass of the volume as the mass of the bar m, and we can write the volume as the length of the bar times its cross-sectional area. That's the volume of the bar. And again, we know this mass, which is 2.1 kilograms. We know the length of the bar to be 0.83 meters, and we know the cross-sectional area to be 1.3 times 10 to the minus 4 square meters. So hence we get the mass density of this material to be 1.9 times 10 to the 4 kg per cubic meter. So now we have the mass density as well as the speed of sound in the bar, and hence we can find Young's modulus. So Young's modulus for this material that the rod comprises is equal to the density of the material times v squared. And this is 1.9 times 10 to the power 4 kg per cubic meter multiplied by the speed of sound in the bar, which is 4.4 times 10 to the power 3 meters per second, all squared. This gives us a value for Young's modulus of 3.7 times 10 to the power 11 newtons per square meter. So if we go to our tables, we can see that this value for Young's modulus corresponds to tungsten. So we can assume that this bar is most probably made from tungsten.